Welcome back to the shop. Today we are going to try out the new 3.1 firmware for iGates and digipeaters. And also we're going to try the Wireless Stick Lite. A few months ago I was trying the 3.0 version and it turned out that the power draw was not as low as I was hoping. But according to Ricardo Guzman, that was because I was using the wrong module. So I have since gotten the Wireless Stick Lite and we should get down to the really low power draw with this. So we are building a wireless digipeater, battery operated for LoRa APRS. We're going to build it into a weatherproof box and with an attached antenna. And see how long that thing will run on these four 18650 cells. So that sounds interesting, then please stick around. First thing I need to do is connect up these battery holders. I need to solder wires onto the ends and connect them up. We're going to connect all these in, let's see, in parallel, so that we end up with the nominal voltage of one cell into the wireless tracker or the wireless module, and hopefully that's going to allow us to use the charge circuitry and also the voltage detection circuitry in this to make an estimate as to the remaining amount of power in the batteries. So let's see if we can solder something onto these without melting them. I think using some flux may be helpful here. Let's see what we can manage. Can you see this? Yeah, we could always zoom in a little bit maybe. And yeah, like that. Let's see if we can get this done without melting the plastic. We got at least one. Yeah, I don't know. No. I think I'm gonna try to get some of these with the wires already attached. So I'll be back in a little while. Yeah, here we go. Let's use these instead and try to just connect up all the wires. These are going to be epoxied into the enclosure side by side, so let's try and keep the wire lengths sensible. But yeah, I think this is going to work fine. Yeah, basically I think what we could do is just connect all these four wires and the positive wire for the powering of the unit. Just connect them all together and we should be done. Now, the thing is with these cells that we're going to put in there, if you do put them in parallel, it's rather important that they are balance charged before you start. That is to say that ideally they should be of pretty much exactly the same capacity, and even more important, they should be at the same voltage when you connect them up. Because if you don't, then energy will just flow from one battery to another. And that can be pretty violent because these can deliver very high current. So I have, I have balance charged them already. I have capacity tested them. They are very close, within 1% of each other in capacity. But It's been a few days, so can you see that? Yep. Let's just double check. 4.212. 4.212. 4.212. 4.213. So within less than or equal to 1 millivolt from each other. I think that's pretty acceptable. And now I need to do something to clear up this this mess, or do I? Maybe I don't. Maybe we can just leave that as is. What we will need is to glue these into the enclosure, and yeah, I'll try hot glue. I'm not convinced that's going to work, but we will try and see if that's sufficient. If not, we will have to scrape that off and do some epoxy instead. But we'll start by trying hot glue. Yeah, that's it. We have the battery box, the batteries, room for the batteries, and we have connected up the power supply for the LoRa module. Good stuff. Next up is getting the antenna in place. And let's see, bottom of this antenna is an N connector. So we'll use one of these chassis N connector to SMA connectors and fasten it at the top here. But we'll need that to clear the batteries, and also we're going to use a filter, because there's lots and lots of noise around these frequencies. So I'm going to use a 433 megahertz filter inline, and that needs to clear above the batteries. So, but let's see if we can mark off about where that is. So that looks like about there, wouldn't you say? Yeah. Yeah, that's good enough. And then we need to figure out how big a hole we need to fit this through. So let's just approximate that and say that that's 16, probably 16 millimeters. I don't have a 16 millimeter drill bit, but I have this step drill. So we'll do first a small pilot hole. Let's see, about here, yes. Can you see this? No, not at all. Maybe now, yep. Start with a small pilot hole, and we will use the step drill bit to widen that up to at least 16 millimeters. Maybe we'll need some more. Let's find out. Can you see? Yep. Let's see, will that fit in? Nicely. Ah, it's even much too big. So, I learned a nice trick watching a video. They said that if you just glue this down and then drill the holes and screw it in, it's not going to move around so much, and it's going to be easier to get the hole pattern with the 4 holes where they need to be. So we'll try that. While the hot glue gun is still hot, we'll stick some hot glue underneath here. See if we can stick that onto here, exactly where we want it. It should be about there. Oh, this sets quickly. Yeah, but it, it really doesn't attach well. All right, that does not, it's not promising for the battery box. So pretty much useless. All right, we'll do it the old way then. Is this a good diameter for the holes? Yes. Let's To be fair, the guy that showed me the trick, he used super glue, and I probably should have used that as well, but yeah, can't be bothered now. I'll just drill these up, try my best to get it in the center. And the last one. Yeah, then next up we need some, what dimension is this? I think it's 3mm. Let's have a look. 3.2, excellent. We need some 3mm bolts, and they need to be how thick? Need to cover the flange and the thickness of the case, so that looks about 5 millimeters, and room for a nut. That's 7, 8, 9 or 10 millimeters, I think. 10 millimeters is probably something I have. 10 millimeter M3 bolts. And luckily, it seems we have enough of those. Ideally, we'd want some of these. I never can remember what the head is called, but these should fit nicely into the top of the connector, and they do. So hopefully we can find 4 of them. Come on. There we go, 2 more. And the last one is always interesting to see if that fits, but it does. Most excellent. So, some nuts and maybe some washers. And I think this is called an Allen key in English. What we need to fasten those. Guessing this is the right size, and it is. Amazing. So for each one washer and a nylock locking nut. I'll just enter it on all of them, and then we'll fasten them up. Maybe even fast forward through some of this, because it's not really that interesting to watch. Let's put the batteries in and see if there's yeah, this is the problem with buying things from AliExpress and other places in China. I see now that this doesn't have a spring on it, so we need to nope. Apparently this is going to be a 3 battery, 3 cell solution. Damn it! Yeah, I should of course have inspected these battery holders before I put them in there. But as you can see, I hope, let's see if we can get some light in there. Yeah, this one doesn't have a spring. So there's going to be 3 cells. All right, we will try that then. 2. And 3. Let's see, are we able to measure the voltage on this one? This is going to be tough, but let's try. See, can you see the screen? Yes. Let's try not to short this while we're measuring, because as I said, these batteries they have an awful lot of energy in them. You don't want to short them out. That's the one. That's the other, and that's 4.211 volts. Yep. Excellent. If this works out, I'll for sure replace this with a proper battery holder. And ready to mount some more of the stuff going in here. The bandpass filter for 33 megahertz bandpass filter. This is also from eBay, but I gotta say it's at least this one is it's fairly good. I was receiving very little on my home station before I put this in, and when I put it in, that actually helped an awful lot. Because the radio in these modules, at least the other ones that I use, they desense very easily from all the other noise around on the 70 centimeters handband. There we go. That's one. And this is the, we don't need the nut and the washer on this one. You can just connect it like so. And then that's ready to be put on there. That's I think is pretty much it for the inside of the enclosure. So I'll clean up and we will install the latest firmware on this one. I'll meet you back as soon as I've cleaned up this desk a little bit. To flash the module, we will go to the web flasher for the iGate firmware. I'll leave a link for that in the description below the video. Here we get to decide what board we have, and let's see if we can find this one. This is called the Heltec Wireless Stick Lite. Let's see if that shows up in the Heltec Wireless Stick Lite. And ours does not have a display, so I'm guessing it's version 3. And we want, of course, the latest firmware, the version 3.1.2 from September. And we want to do a flash and a factory reset. Let's see, we will flash. We have a COM10. We'll do connect. And we will say install. And we will erase and install. Says it's going to take 2 minutes, so if that's true, we will speed up this section for sure. Installation complete. That wasn't too bad. Next, let's see. We can connect and have a look at the logs. And the next thing to do to configure this is we open a new tab, and we also try to see if we have a new wireless network, and we do, which is no-call 10AP. This is what we're going to connect to. There we have it. We've connected, and it says no internet as expected, and I think the IP address is 192.168.41, isn't it? There we go. Ah, how nice. So, time to configure. I've had some issues before with, yeah, I'm seeing this again, no, with this thing disconnecting while I'm actually configuring it, which is bloody annoying, but let's hope we can get out of that this time. We'll do Lima Bravo 5 Juliet Juliet -10, that's good enough. The beacon comment, LoRa APRS, that's a boring comment. let's say battery powered iGate. And the beacon path, yeah. Oh, this is not a Norwegian keyboard, not at all. Let's see. There we go. Wide 2, wide 1.1 and wide 2.1, I think. This is only for testing. If you place this into some sort of existing LoRa APRS infrastructure, then you need to coordinate this path, of course. Can't remember what I'm meant to use here, but I think we'll use the black diamond with L. And yeah, I need to find the coordinates. I'm using an app on my iPhone to get the location, and that says that the latitude is 59.27 and the longitude is 10.41. It's close enough. I don't think we need a personal note. We will not send status on boot, and we will also not connect it to a network. That's an important part in keeping the current draw as low as possible. It's not going to use the wireless networks at all. It will only do iGating. So we need to not enable Internet APRS IS for any sort of interaction, but we will enable beaconing. We will send in beacon via RF. We will do that every, for testing purposes, we'll do that every 15 minutes. I think that's all right. And next up, we will not blacklist. We will do digipeating. And we'll do digipeating as wide 2. But we will turn on Ultra Eco mode, sleep till packet RX. This is what we tested a few months ago, and this is what's going to draw even less power on this module. So this is what we need to enable. We enable LoRa TX and RX. We have the frequency of 433.775.000 Hz on RX and TX, a 125 kHz bandwidth, a spreading factor of 12, coding rate of 5 and 20 dBm power. That's 100 milliwatts. Display is not always on at all. Not that this thing has a display, but if it had one, it wouldn't be on. We want this to send voltage, internal voltage, I'm guessing, yes. And as telemetry, no, let's just keep it not as telemetry. Then I'm assuming it's just gonna send it as part of the text it sends out in its beacon. Max voltage on input pin is 3.3 volts, yes. Monitor enter, no. Monitor external, no. Voltage divider, I don't know. Let's just leave this as is. Just that these are sensible defaults for this one. We will not do any telemetry. We can't do any syslog because we're not on a network. And we will not enable any TNCing. And here, this is a very, very cool thing, MQTT. We will do another video where we show off some of the cool things you can do with when you integrate MQTT with LoRa. But for now, we will leave that disabled as well. Reboot time, no, we will not need that. Auto AP, no, we will not set a password or do anything about that. Over-the-air updates, not interested. Web interface, not relevant since we're not doing any networking. And remote management as well, we will, we could enable that, but we will not do that for now. Maybe we'll do that another time. NTP is a network service, we don't need it. And backup digipeater mode is not relevant for our config. Let's see if we are still connected to the... no, we're not. So this is an important thing to remember. When you spend too much time in the configuration, you will probably be disconnected from the wireless network on there. Microsoft, in their infinite wisdom, just figured out that you can possibly have any interest in staying connected to that thing. So please reconnect before you save your settings, or they will be lost and you have to do it again. And that's just bloody annoying. And it's connected once more. Excellent. So we go back here and we press the save button. So we have the LoRa module connected to the antenna via the bandpass filter, and we have the power wire connected in here. So the last thing that remains to do now is connect this to power, now that it's configured. And just to verify that it works, we will turn on a couple of trackers. Let's see if we can see. Oh, that's an awful lot of glare there. How about you? We'll try and, okay. Zoom in a little bit. Yeah, that's as good as it gets, I think. Sorry. What we expect to see now is that when we power this thing on, it should send out a beacon, and we should see that appearing on the screen of these two trackers. Let's see. There we go. Most excellent. That probably means this worked. So the last thing to do then is finding some way of attaching the module. I think we will do that with hot glue as well. Well, that's more than a little bit, but okay. Let's zoom out a little bit so you can see this. And we'll stick that down here and attach it to the side like that. That, in theory at least, should be sufficient. And if this turns into any sort of permanent installation, I may tidy up a little bit more in here. For now, we'll just keep this really simple. Let's get all the positive wires up on top and all the negative wires down below. And let's reconnect the antenna. And last of all, let's put a lid on this one. There we have it. That's the last step completed. What remains to do now is actually testing this. We have quite the awful weather in Norway today, so I'm not going to try and test this outside today. We will leave it powered on and see how long the batteries last, and I will create a follow-up video, both with information on how long the batteries last, and maybe also even one where I place it outside to see how it works. But anyway, that's it so far. So if you want to see how that turns out, please consider subscribing. If you liked this video, give me a thumbs up. If you saw something dumb that I did or have any suggestions for better ways of doing it or other things that I should try and do, please leave a comment. I'm learning a lot from that as of late. Other than that, I will just say till next time, thank you so much for watching.